Alright, in this section 2.3 we talk about getting information from a graph of a function. So the first thing is they give you a graph here and they ask you where is it, they say a function has a local maximum value if f of a is the largest value of the function. And then they say from the graph we see that there are two local maximums. Here you go. And one local maximum is 7 and it occurs when x equals 2. The other local maximum is 6 and it occurs when x equals 5. And then they ask you the function has a local minimum if f of a is the lowest point on your interval. From the graph we see that there's a local minimum value of 4 at 2. Okay, so question number 7 shows you a graph and it says find h of negative 2. Well, you go over to negative 2 and you go up and you get 1. H of 0, you go to 0 and you drop to minus 1. H of 2, when you go up and you get 3. H of 3 and you get 4. Now they ask you to find the domain. Domain is simply just your x values. Well, it goes as far left as minus 3 and as far right as 4, so minus 3 to 4. Your range is from minus 1 to 4 because it goes as low as minus 1 and as high as 4. One of the ways you can think about it is you can take the graph and squish it onto the x-axis like a pancake. If you squish it on the x-axis, all these points above come down and stick to the x-axis and all these points below come up and stick, and so you're looking at minus 3 to positive 4. And same thing with pancake approach on the range. You can squish it onto the y-axis and wherever it sticks is your range. It sticks from minus 1 to positive 4, and so minus 1 to 4. And then question 7c says find the values of x for which h of x equals 3. H of x equals 3, meaning y equals 3. Well, y equals 3 is right there, and it hits at 3 places, minus 3, positive 2, and positive 4. Okay, and then D, find the values for which h of x is less than or equal to 3. Well, we know where it's equal to 3, these 3 values, but less than is down here, lower than where it is at 3. So we're going to include from minus 3 to positive 2, but we also include the number 4. Then 7e says find the net change between minus 3 and 3. That means take the difference of their y values. Well, 3 is 4, and minus 3 is 3, so 4 minus 3 is 1. Okay, question 8. They give you a graph here and they say what's g of negative 4? Well, it's 3. G of negative 2 is 2. G of 0 is minus 2. G of 2 is 1. And G of 4 is 0. Now what's your domain? Well, it goes as far left as minus 4, as far right as positive 4. So minus 4 to 4. What's its range? It goes from as low as minus 2 all the way up to positive 3. And then 8c, for which values of x is f of x equal to g of x? Or excuse me, that's for question 9. Question 8c is which values is g of x equal to 3? Well, here's 3. And if you draw a line, you only hit there. You don't hit there. That passes through. So it's equal to 3 for negative 4. Okay, then D says estimate the values for which g of x is less than or equal to 0. Well, less than or equal to 0 is from minus 1 to a little bit less than 2, so I said 1.7. And it's also equal to 0 at 4. So minus 1 to 1.7, including 4. Then they say find the net change between minus 1 and 2. Well, 2 is 1, and minus 1 is 0, so 1 minus 0 is 1. You always take the larger x value and subtract the smaller x value. You get the y coordinates for each one. Alright, question 9. They give you a graph here. Here's f and g. And they say which is larger, f of 0 or g of 0? Well, f of 0 is up here at 3. G of 0 is down here at negative, so f of 0 is larger. Which is larger, f of negative 1 or g of negative 1? F of negative 1 is up here, positive. G of negative 1 is negative, so f of negative 1 is larger. For which values of x is f equal to g? Well, it's where they intersect, at negative 2 and at positive 2. Then for which values of x is f equal to or less than g? Well, we know where it's equal to. Where is it less than? Well, where f is lower than g. So here, from minus 4 to minus 2, and from here to here, from 2 to 4. So that's how you would write that. When they say less than for a function, they're meaning which one is lower than the other. Then E says find the values for which f is greater than g, where f is higher than g. Well, that's in the middle here. And they only want greater than, so they're talking about between minus 2 and 2, not including the endpoints. Okay, then question 21. They say the graph is given, or a function is given. Sketch the graph and use the graph to find the domain and range. Alright, so x squared minus 1 from minus 3 to 3. You can sketch it on your calculator. If you only look at from minus 3 to 3, you'll see this graph here. Your domain, minus 3 to 3. Your range, it goes from minus 1 to positive 8. If you look at the points, you'll see that that's what it does. 31. Solve the given equation or inequality graphically. So the first one is x squared equals 2 minus x. So if you graph x squared and you graph 2 minus x, both graphs, if you're looking for equality, we look for where they intersect. So at minus 2 and at positive 1, there's your answers. Now this one says where is it equal to or less than 2 minus x. So we're looking at the endpoints, but where is x squared smaller or lower than at 2 minus x? So we're looking at minus 2 and 1 and everything in between. 32, same idea. You graph the left, you graph the right, and you get this parabola and this line. It's really a tight graph. It's hard to see what's actually going on there. But here the x squared is higher than the line is. Well, where are they equal? At these 2 points, at 1 and 3. Where is minus x squared larger? That's where minus x squared is higher. So it's higher between these 2 points and equal to those 2 points. So 1 to 3. .34, same idea. Where are these two equal? Well, if you graph both of them, they intersect in 3 different spots. Now let me show you how to graph those two and find the intersection points. Type in 5x squared, subtract x cubed, enter. You type in negative x squared plus 3x plus 4. Okay, and if you hit zoom 6, gives you a nice graph. The first one is 5x squared minus x cubed, it's blue. The second one is minus x squared plus 3x plus 4, the red one. Okay, and if you look at it, you see it intersects here, here, and here. Now how do you find those intersection points? Second trace, intersection is 5. So type a 5. Now you want to move to the intersection point first. Then hit enter 3 times. And it gives you the first one at minus 0.58 or minus 0.6 and 1.9. The second one, hit second trace 5 again and move to the next point and hit enter 3 times. You don't have to be right on top of it, you just have to be close. And then 1.29 is roughly 1.3 and 6.2. Now how do I find this last one? Same idea. Second, trace, 5. And I move all the way to the other point. That'll go quite a ways. Now I hit enter 3 times and I get 5.28 or 5.3 and negative 8.1. So there are my 3 numbers where these two are equal, the x values. Now where is this guy less than this guy here? So remember, the 5x squared minus cubed is this one, so we want this guy to be lower. So there's where it's lower, and there's where it's lower. So we're looking at minus 6 to 1.3, and greater than or equal to 5.3. So notice here, this is where the 5x squared minus x cubed is lower than the right-hand graph, and this is also where it's lower. Okay, so we want these two values here and greater than this value here. 37, they give you a graph and they ask you to find domain and range. So your domain is minus 1 to 4, your range is minus 1 to 3. And where is it increasing? Well, it's increasing from minus 1 to 1 and from 2 to 4. Where is it decreasing? From 1 to 2. Alright, 38, you got this graph here. Domain, well, minus 2 to 3. Range, it goes as low as minus 2 and high as 3, so minus 2 to 3. Where is it increasing? From 0 to 1 is increasing. Decreasing, minus 2 to 0 and 1 to 3. And finally 40, same idea. Domain, it goes as far left as 2 and as far right as 2, so minus 2 to 2. Range, it goes as low as minus 2 and as high as positive 2, so again minus 2 to 2. Where is it increasing? Just here, from minus 1 to 1, bracket on each side. Where is it decreasing? From minus 2 to minus 1. Notice there's no bracket on the minus 1. And then 1 to 2. Notice there's no bracket on the 1. And for 44, they give you an equation and they say graph it on your calculator, find the domain and range, state where it's increasing and decreasing. So you look at this guy, and I found these low points by, let me show you how I did that. You hit y equals and you clear out what you had before. So you type in x hat 4, subtract 16, x hat 2, and then when you hit graph, it's typically not going to show you what you want. But one way to make a nicer graph is to hit zoom 0. Oops. Zoom 0. And that's asking your calculator to change the coordinates on the y-axis. And that didn't really help us too much. So let's try, go back to zoom 6. And what we see here is that we're not seeing the entire graph because we know it comes down here and here. So we can do zoom out. So zoom 3, enter. Whenever you zoom out or in, you have to hit enter. So here's our graph again. Now let's zoom out some more so we can see the bottom here. Zoom 3, enter. Okay, now our graph is in here, but it's really tight and hard to see. So this is one thing you can do to help you to zoom in. It's called zoom box. So zoom 1, and you move your arrow, little plus sign, until you can see it where you want your imaginary new screen to be. So I went to the upper left of what I wanted. Then I go down until I get what I want and I hit enter.